This is the DCX. And I fell in love with this rocket when I seen it on the Discovery Channel. I bought the small kit. Love the way it flies. It fights for every foot of altitude that it gets. And I attempted a upscaled version of it before on 5Gs, basically, 29 millimeters. And it didn't fly so well. This one, it's got a little bit more power, and she's a little better built too. You get better as you go, you know. And so, but I'm proud of it. I'm a little nervous. I'm going to attempt to cert level 2 today on this, which is kind of off the wall. I should use something a little simpler design, but I'm not that type of guy. I like to push the envelope. A lot of people bring tubes out, and this is what I show up with. It's a McDonnell Douglas design. They did a DCX, and unfortunately it's retired before it ever got into any kind of service. But what it was basically built for was an SSTO. That's a single stage to orbit, and the turnaround rate from coming back from space was supposed to be within 24 hours, and it's supposed to have a minimum of maybe 5 to 10 people as a ground crew. Send it right back to space 24 hours later. The cost to get it to outer space is maybe 30,000 to 40,000, you know, to put it up. And it does a lot of impressive stuff. During the test flights, during McDonnell Douglas's test flights, they got it up to an altitude, I think it was 1,000 feet or 1,200 feet, and then hovered straight across and come down and landed. And that was pretty impressive. That gets me fired up. I've always loved science fiction, space movies, things like that, but I never launched a rocket. And then I went to work for a good guy, Bill Cleary, and he bought me my first rocket. He had been launching some just hobby rockets, you know, off the shelf at the hobby store. And it was just G class and under, and he said just pick one out, and I built it, and ever since then it's gotten extreme now. There's certain fundamentals that you definitely need to know about right off the bat. CP, which is center of pressure, CG, which is center of gravity. All this is real critical in flight, or you're going to have an unstable flight. And then you can modify the kits. I've done many of those, and I personally prefer to certify on scratch-built rockets, just built from no instructions, no kits, and that's what this is all about too. What I love about this hobby really is just that it taxes my mind so much. I mean, I learned so much from this hobby. I mean, the science in it goes in many different directions. If you're into electronics, you know, it's there for you. If you're into design and structure, it's there for you. Okay, this is a Dr. Rocket reloadable motor system, and this is my pride and joy, really. I take a lot of good care of these. This is a K550. She's gonna burn for about 3.1 seconds, and peak thrust is about 200 pounds of thrust. It ought to move this rocket real nicely. And then as soon as the motor cuts off, the drag's gonna take effect, and she'll just throw the brakes on. She won't coast a long ways. But I'm running the plugged forward closure. It's got a Medusa nozzle, and which this is my first time ever, you know, for a K. It's my level 2 attempt, and I was a little nervous. It's exciting packing these motors. I mean, because you're doing some pretty impressive stuff. I mean, it's you know, it's getting big now. The holes, what that does is that allows the propellant to come out of the holes. So if you open up more holes, then you're going to let the propellant, you know, exit the casing a lot faster. And so And so, and the least amount of holes that you got means more restriction on the flame coming out. So you're gonna get a lot slower burn time, and it's gonna burn a lot longer. And now the more holes you got, the more fire she's gonna throw out, and a lot hotter lift off. I got mounted a key switch in the bottom of the rocket, so you see this out there on the launch pad, you know not to launch it for sure. So that's kind of basically what that is just a big reminder to arm your electronics. Here is the K550 where she'll go, and then here is for my outboard 29s. And so I've got an electrical conduit that comes out right here, so I can lift off on the core motor and then air start the 4 outboard motors. And I think that would be pretty spectacular. Let me take this nose cone off, and we'll get this shroud. I got composite graphite, carbon fiber on the top up here. This will help in case of a zipper, maybe, help strengthen this tube up. And I've also got it on the bottom of the rocket, kind of a heat shield type deal. And the shroud comes off. It's made out of styrene. And this is my altimeter bay. And right here is a blast plate. I take these these screws out, and there's 2 conduits that go inside of this tube, which there's my parachute. And so I'll top load my ejection charges in, bring them out these 2 holes, run them down these conduits, and then plug them into my altimeter. Then I turn my key on, and she should be ready to rock and roll. This is all aircraft plywood. I cut all the holes in it to lighten the load. And my outboard 29s are all on the outside of this 4-inch airframe here. And it's a lot of design, a lot of structure. That's what I was saying. I'm a big fan of the design and engineering of it. Here's just basically the same thing as what's on the other side, except for this bay is designed to hold a timer. And I've got 2 electrical conduits that I was showing you on the bottom. This is where my igniters will go. They'll run down here, and then I can plug them into the H128s, the 4 outboard motors. She'll be coming down on an 8-foot parachute, which is a little big, but I mean, I can't have any damage. And she's actually pretty tough. Now a stick or a stop or whatever could punch a hole in this, and I hope that doesn't happen. But this shroud will be screwed on, plugged on, and then we'll just be left up to the LCO to set her off. That was a beautiful flight.
Yes, it was.
Yeah, that's why I love that rocket.
Did it go exactly how you thought?
Yeah, the ejection was early. You know, that just, I guess you get better with experience, but the only thing I can think of was as soon as the Mach delay inhibitor timer quit, you know, started taking pressure readings, then it pressure spiked and popped, and so, but it's no damage.
So about what difference in time would that be, would you figure?
Maybe a 6, but I don't have that setting on my altimeter. I've got a 4, an 8, and a 12, so. All right, my prefect's inspecting my rocket right now.
Congratulations.
Fixing to sign my paperwork. Thanks a lot, guys.
See you.